Well, welcome to part 3 of our data science primer. This one is on software in research and statistics. This is a dream come true for me. This session, it'll be the most challenging for me to present and probably for you to consume. You know, I've been through numerous, tutorials on software, and it's like, wow, wouldn't it be cool to be able to do that someday? So this is literally my first crack at it, and so it'll get better as we go. We have a lot to cover. Remember, we have the notes page. I'll resend that out afterwards. Also remember that I'm recording, so don't worry about frantically taking notes. Try not to worry about the details, because you can always go back to the video, and a lot of the examples are embedded into the notes page. And finally, if you still need additional help, you always reach out to me directly for that assistance. So today, our goals, we're going to learn some basics. We're going to go into SQL. We're going to learn some basics of HTML and CSS. And we're going to dig deep into several of the programs that are used for statistics, digital programs. We've been primarily focused on R and Python, but I'm also going to go into Excel. I'm going to show you how this works in SPSS. You may or may not have access to SPSS, but you'll get a feel for how it works there, and you'll be able to compare it to some of these other tools. And finally, there's a program called Genovi, if I pronounce that right, which is based on R, but it looks a lot like SPSS. So if you like SPSS, but don't have access to it, and you're comfortable with R, then that might be a good option for you as well. So I'm going to go out of my presentation, and we're going to do a lot of the stuff here literally right on the screen. And the first place to start with this really is even just learning the command prompt. Why am I going to teach you how to use the command prompt? Well, a lot of these tools require the use of the command prompt. A lot of updates occur via the command prompt. And there's a related program which I'm going to show you called GitHub. And GitHub also uses the command prompt. So when you open your computer, if I'm on a Windows, there's instructions in the guide on how to use this on a Mac. But if I'm just trying to figure out what's in my current directory, I can just hit dir, and it's going to give me everything on the directory, on this C drive, users, Patrick Dunn drive. I may need to change that. I may need to go to a different drive. So I'm going to go to my D drive and see how it changed from the C drive to the D drive. And the tools that I'm using in this course are in a directory called Your Heart Score /data science. And then the computer programs that we're working in is called, in a folder called code. And of course I did that wrong, didn't I? Oh, I didn't. You know what I didn't do? I didn't do change directory. Okay, now we're in the code directory, and now I can do the same thing. I can hit DR, and these are actually all of the files that we see in the directory. I have to keep my own notes going here. So why do we need to know this? Well, maybe we want to see some of the output from some of these files. So I'm going to use Python as an example here. So if I want to get a Python output, type in Python, and then the name of the file. There's a couple of files I want to show you. I'm going to tease them here, but we'll show you how they were created. If I go to this GDMT, which is Guideline Directed Medical Therapy, and open up the file, and it's actually going to create the output. This is actually output of a fictitious patient initiating and then optimizing their heart failure guideline-directed medical therapy. I've created another file. Which creates, and so that took a little bit longer to create because there's a little bit more code involved here, but I've actually created a database. I've stored the records, I've logged to the database and saved those records. And I've actually created a scoring mechanism based on some key factors in heart failure disease management. I've created scores based on nominal responses, and I've created an algorithm for how this patient, in this case, should recheck, whether it's in 4 weeks, 1 week, or 2 weeks. So we'll get more into this a little bit later in the segment today. But again, just some basics in the command prompt. The notes page has a lot more thorough inventory of command prompts. You can make directories, create directories, you can delete directories. So a lot of stuff that you can do there. Another program I want to tell you about is a program called GitHub. And again, these are related. So you really should be pretty good at the command prompt before you start creating your own GitHub resource. But the purpose of GitHub is to be a version control system. So you can actually create your own directory on GitHub, and you use the command prompt to actually make updates to this. So I've created a directory here. You'll recognize these files. I have this gdmt file right here, and it's this actual page in Python. And so you can go in here and you have full access to this. So you can go on, it's github.com. You can search for Patrick J. Dunn, data science, and you can get access to this page. I can certainly give you the direct link to this page. So you can follow all the work, and I'll just continue to post code files, not just Python, but the R files, the SPSS files, all of the stuff that we're using, I'll create in here. So we'll have this, ongoing. And if I ever go back and update this page, I'll use this system, so you'll always be able to see the most up-to-date. Another benefit and feature of GitHub, let me just go back to my home, is even if you're not looking for me, you can be looking for other things. So if you're looking for you can just type in some keywords, and it's going to pull up just some amazing resources. And it's a search engine, so whatever you decide, to pull up, so you can you just put your search terms in, and then you basically can go into other people's directories. This one is an empty directory, but you get the point. You can play around here, and you can actually learn how to code by looking at other people's code. Okay, so that's GitHub. Next thing I want to go over with you is, we have this sample data set. It's called Cardio, and I sent it to you the first day. If you don't have access to it, I can certainly resend this to you, but this is in Excel. And it's super important when you're good, if you want to be really good at data science, to get good at Excel, because it does some amazing things. Obviously you can create formulas. So if you notice in the Cardio data set, it only went up to row N. If you'll notice, age was in days of life. I had to figure that out. There wasn't a code book for this. Also, we have height and weight, but we like to use things like the body mass index. So again, you can go into Excel, you can we can do this in the other programs too, but age is a pretty easy one. You just days of life, divide by 365, don't forget leap years, so 365.25, and it's going to give you the person's age. There's also a formula for the body mass index. You can put the body mass index is weight over height squared, and then you can create these two additional columns. Another feature in Excel is to go to the Data tab and click the filter, which will allow you to manipulate these rows and columns. And I'll show you why that's important. So the other thing I did is I downloaded the data analysis package in Excel. So you click on File, go to Options, and go to Add-ins. And from Add-ins, you can add this analysis tool pack. I've already done it, so I'm not going to reinstall it. But that's what you get over here. If you click on Data Analysis, there's all of these tools that we've been talking about, from t-tests to ANOVAs to regression. And you can do these in these other programs, but you can also do many of these basic skills right in Excel. And I just took here to do some descriptive statistics. Before the session tonight, I ran descriptives here for the systolic pressure and for the diastolic pressure. It's important and it's helpful in Excel to really look at these numbers and don't always take them for face value. This probably looks very tiny here on the screen, but we have a mean systolic of 128. We have medians and modes of 120, so those seem to be okay. But come down here and look at the range. We have a max systolic pressure of 16,020. I don't think there's ever been a systolic pressure recorded that high. So this is pretty clearly a keystroke error here. So it's always important to be able to clean your data. There's also a minimum value of negative 150. So I don't think it's possible to have a negative systolic pressure. We see the same thing with the diastolic pressure. And you can kind of see here some of the, sometimes I think somebody's just putting the entire blood pressure reading into one cell, which is creating the problem. But how do you fix that? Again, if you put the filters on and you go back to this column here, and you can sort now from largest to smallest, and you can see all of these values that really are not probably, and you have to decide in your research, maybe these values here, maybe 240 is a plausible number, but certainly not a 16,000. And you can do the same on the other end too. Give it a chance to run that. Oh yeah, it's smallest to largest. And again, certainly the negative numbers in probably in the single digits, or certainly 11s and 12s. So you have to decide what you're going to do with those data points, but you probably shouldn't be using them in your analysis. So you should probably either deleting them or doing something else with those readings. Okay, so that's just a quickie on Excel, but it's super important to know and understand Excel. Once you get into Excel, you really start looking at data and databases. Again, super important stuff. So again, the web page that I created, so I'm in a program here called MySQL. MySQL is it's an open source database. It's owned now by Oracle, but you can go and you can download it for free. And it's a very popular open source database. There's other versions of SQL. There's MS SQL Express Edition, which is also a free version. Of course, Microsoft and Oracle and others have enterprise versions that are not free. There's another open source program that I like to use that's called SQLite, and you can actually download the client right on your desktop, which can get very handy. With MySQL, you're actually using a local host, so it's a little bit more complicated. But what you do in the case of SQL is you first have to create your data set. Then you have to create your tables. So you should always have an identifier, which should be an integer. So you have to declare the variable. In this case, it's not null because you don't want a null value in your identifier. And we want this to auto increment. So every time you add a new record, you get the next number up. So you create uniqueness in your records. And then you create your other variables. So we have an age, which is an integer. We have gender, which is a variable character. And we only need 10 spaces because it's going to be male or female. You could actually, female is 6, so you could actually put this down to 6 if you needed to. You also want to identify your primary key. In this case, that's your ID. And then you do this for, okay, and so then we're going to enter values. So we're going to enter, we just created a couple records here. Once you've done that, you can create this select statement, and it gives me my values. So select from personal. And then you can do the same with your other tables. So we have a HF status. We create some records in here. We create this table. We can insert records. And then what you want to be able to do is you want to be able to join these tables. Okay, so we want to use this data set. We want to select and we want to join these records together. And now when you do that, see, now I have my personal information and my heart failure program information all in the same row, even though these are coming from separate tables. And the reason that's possible is because of what's called the primary key and the foreign key. Okay, so in each of these data sets, each of the tables needs a primary key, but in the table that you're linking, so if you think of it as the parent and the child needs a foreign key that tells the database which one is their parent, basically. All right, so we have a couple of other examples from this data set. So again, we've added some more data, we've joined, and you can also create now what's called a where clause. So it's these select statements. You're selecting. You're either selecting all of the records, and you do the all records with the star symbol. But you can also select individual columns from both of the tables. You have to say where it's from and how you're joining. So we have medications and patient, and then we're gonna use this patient identifier here. So here's so we've done select from where, and we've joined two tables here. I've also created this is a sample data set. You can go online, sample MySQL data sets, and it's called classic models, and you can create your tables. You can actually, so there's multiple tables in here, multiple data sets. All right, and then we go over here to our sample data, and we can come down here and we can do a select statement. So it's fun to try to get good at doing these statements. And then finally, we're back to our cardio data set. So you recognize this from the Excel table. So again, you can do select all from cardio, and when you do that, this is the, oops, oh yeah, we have to. See, I had to tell it which data set because I'd gone from 3 different data sets. So use the Your Heart database and select from cardio. But then you can go where ID equal to 1. And you select now, and that's how in your code you could go to the individual person in that file. We're going to kill this now, but we're going to go. But you can also, let me go back to my sample. Yeah, let me just put in a couple of additional ones here. So we're going to select age and gender from cardio. So now you just have 2 rows. We can do select all from cardio where age years is greater than 60. And now if you go over here, all of these are greater than 60. And we'll do one more here. Select ID and gender from cardio where age years is greater than 60, and the cardio field here, which means they have cardiovascular disease, is equal to 1. And there we go. And we didn't ask it for the cardio, so that's why it doesn't show up here, but we did put it into the query. All right. So now, and let me just show you a quick example. We're now in SQLite. So now, again, from that code that I shared with my scores, we could do select from scores where that score is greater than a 2. Click here, and we get all of these records in this data set that have a score of greater than 2. You could also do it less than 2, and hopefully we get a different grouping. See, all these now are less than 2. All right, so now let's move on to SPSS. I'll just show you a couple quick things here to note. So we have the same cardio data set. The way SPSS works, there's actually 2 views. There's a data view and a variable view. So in SPSS, you can actually go in here on the back end and you can create labels, you can create values, you can identify what type of measure it is, whether it's a scale, a nominal, or an ordinal variable. If you have nominal variables, so if you have like this smoke variable, and we have smokes as 0s and 1s, which I'm assuming means 0 is not smoked and 1 is yes to smoker. So you do 0, and 1 equals smoker. Now we want to go here and run a frequency table by smoker. And so we have it, even though in the data set it's 0s and 1s, we have non-smoker, and smoker. And 91.2% in this data set are non-smokers, 8.8 are smokers. All right, so to run some analyses, you can go to, for example, compare means. We want to do we're going to do a let's see if we can do a t-test here. So we're going to do this blood pressure variable by cardio, whether they have heart disease or not. We have to tell it what these groups are. So we have 0 and 1. Continue. Okay. And here's our independent sample t-test. We have the Levene's test for equality of variances. It does not pass that test, so we have to assume unequal variances. And we have a 1 and 2-sided t-test. Both of these are at a p-value of less than 0.001. I'll just do one other SPSS. We'll do a, let's do a logistic regression with the cardio variable as the dependent. And then we're going to do, let's do the body mass index and age and cholesterol. So this is the multivariate analysis. Click here, and we have our logistic regression. We have our significance. We have our beta, and we have our odds ratio here. So again, more detail, an entire lecture could be done just simply on logistic regression, but that's how you set it up in SPSS. All right, so now let's move on to R. And let me pause here and take a look to see if there's any comments or questions. Okay.
Yeah, it's been really great so far, Pat. Thanks so much. A lot of interesting data.
All right, so remember that in R, there's R and there's also R Studio. Yeah, and it works the exact same way in R. The R Studio gives you a little bit more functionality, but if you just like one screen for inputs and outputs, you can certainly do the exact same analysis using R. But the way it works, I just have a couple of things set up here. So some basic numbers. So 1 plus 2, we've assigned values. So A equals 1, B equals 2. We're going to print A plus B, and the output is a 3. It's also important to set your working directory. So you can set the directory and then get the directory. So again, all we're doing here is we're highlighting and hitting run. And you see here, you can see this working directory sitting right up here. You can also pull in a data set. So we're going to read this cardio data set, which is sitting in this folder. And all it did was read it. It didn't do anything else, but now we want to view it. So we're going to click. And now we have our data frame sitting up here. You can get to the data frame a couple of other ways too. You can click on Files. I'm in this R data set here, and this is my cardio data set. So I can also just double click here and view file. It's already there, so I don't need to put it up there again. But that's another way to go to your data set. So I have a couple of other files. I have this HL data set, so I'm going to view this, and I'm viewing it here in R, but I may want to have a little bit better view of it. So I'm going to click back here. Well, let me go to the summary first. I jumped ahead. in this cardio data set, I can click, and I can get basically the same values that we saw in Excel. If you look at these systolic and diastolic readings, they have the same problematic information with the ranges. I have this other data set here. It's this HL data set. So I have this up here, and then I can view that in a data frame. What I'm going to do here is I'm just going to click it's called head. Click here, and it's just going to give me the first 6 rows. If I want to run some statistics, and I want to do, like, say, a mean. So I want to do the mean age, and let's do the mean age here. I do the name of the data set, followed by the $, followed by the value. So click here, and here's my mean for age. Remember, this is in days of life. I may want to have a count. Oops. So I can do count cardio. It's going to give me my 70,000 records. I may want to just have a head for an individual variable. So for weight. Now, as we said before, we need to do some calculations. So to do a calculation, you identify the variable. You use this less than sign with the dash, and this is we're creating a new variable here, age years, and we're putting in the formula. So if I click here and click run, and we need to do the same with the body mass index. So I'm going to create this calculator, click run, and now those have been added to my data set. Couple of other quick things. All right, so we're going to do we have another data set in here for motor cars. We can do a data frame in here. So you may just want to create a table. So you can create a table. Again, you just identify your columns. You either enter the numbers or you reference the variable, and then you create the data frame. Here's one for creating a histogram. This one, let's see, customized appearance. And let's see okay, so I created a histogram, and notice over here we can actually plot this, and you can actually save this as an image. You can save it to a clipboard, a PDF, or as an image. We can do the same with a scatter plot. Here's our scatter plot. And same thing here. We can do a histogram and a t-test. Okay. All right, and now we're going to get a little fancy here, and I'm going to show you this in Python as well, just to round out R. So the key to R and to Python is installing packages and directories. So where do you get those? How do you know what those are? So you can click over here under packages. The reason that R and Python work so well is they're pretty light applications. And then what you do is you then ask it to import the information that you're needing. Okay, so we're gonna load the package for random forest. I've already done that. And install the package that really creates it's basically a grammar for data manipulation. I've already done that. So now I'm just gonna load my data set, and I'm gonna do a random forest analysis of Titanic survival ships. So people that were on the Titanic, and there's some key factors that, whether they were in which class they were in, so first, second, or third, whether they were male or female, their age, and how much they paid, and also where they embarked from. So there were three. There was Cork, Southampton, and Queens something. So one in Ireland. So the people in Ireland, third class, young males, they had no chance of survival. And so this is going to run a pretty complicated analysis. I'll show you this exact same analysis in Python, which you can actually play with the numbers and actually predict whether you are going to live or die riding on the Titanic that night. Now let's move to Genovi, because if R seems a little complicated for you, then what you do is, first of all, you can load your data set. So you're starting to recognize we have the same data set going on here. You can compute new variables. So I've computed this age year. I haven't done with the BMI, but we can do that. We could transform the height and weight variables and then create the BMI calculation. You can come over here, and just like in SPSS, you can get more specific on what these variables are, even whether they're scale, and it even has the same icons, the scale or the nominal values. And then you can come to analysis. So if we want to run, again, want to run that independent sample t-test. So first of all, we need to select our variables. So we're going to do this systolic blood pressure. We're going to do it by their cardio. It doesn't need to know whether it's zeros or ones. It's already pretty much figured that out. And then what do we need to do? So we want the mean difference. We want the effect size. We want that Cohen's d test. So Sammy and Ahmad, we were talking about this the other day. It's literally clicking that button and you got your Cohen's d. You could even do a confidence interval. You can click on descriptives and get your descriptive analysis. And you also want this homogeneity of variance test. And so you've got your assumptions, you've got your descriptives, and it's literally doing the analysis as you click the button. So you don't even need to do a, run. It's running as you go. Even your hypothesis, is there a difference? Is it greater than, or is it less than? So it does a lot of the work for you. And it even puts the tables in APA format. So these are pretty much good to go with, going to a journal, which we're going to talk about next week. So that's a t-test. Let's try a one-way ANOVA. So we have 3 cholesterol values, and let's do diastolic here. So, and we're going to do our homogeneity test. We're going to do our descriptive table. And again, so see, we have the 3 values. Now, remember also in ANOVA, you also need to be thinking about your post hoc test. So we don't have equal variances. So we're going to do the Games-Howell test as a post hoc. What does a post hoc do? It actually compares each individual value. Okay, so the 0 to the 1, the 0 to the 2, the 1 to the, you get all of the different scenarios. And it does it in a much more elegant way than SPSS. SPSS basically double counts and fills in the entire matrix, even though there's no difference between the 0 and the 1 and the 1 and the 0. So anyway, that is, let's do one more. We can do a regression. Let's do a linear regression. And we'll take Again, we need scale variables for this. So let's take our, let's take our systolic pressure, and then you can put your covariate, and your covariates can be both scale and nominal. So let's put our diastolic, we're just doing this for examples, and their cholesterol, okay? And then you can build the model, you can do your assumptions, you can do, if you're doing analysis of covariance, you can do your estimated marginal means. So again, a lot of stuff to play with here in Genobi. And then finally, logistic regression, very similar. We're going to have a binomial logistic regression. So the obvious one here is we want to see what's predicting cardio. And so again, we can put any of these variables in here. So we'll put the cholesterol in as a factor. We can put weight in as a covariate. And then the same thing, we're going to check here for collinearity. We're going to do our Nagelkirche pseudo R square. So again, a lot of different options here, and it gives us our results. All right, now we're going to move on to Python. And I have to thank you all. You have really helped me up my skills in Python in doing this. So because to be able to present this, I had to really learn in a much deeper way how to use Python. I showed you from the command prompt, you can actually call the Python file and it will produce the output. What I'm showing you here, it's pretty small, but on the left, and I'm using a program called Spider. There's other programs. I showed you, you can use Visual Studio. You can also use a program called PyCharm. But the way all of these work is within Python, you're going to import what's called pandas. That's basically your library for doing quantitative analysis. And then there's another one from time to time that you'll use that's called PyCharm. So again, what you're going to do here is you're going to import here, and then we're going to load these data sets. So again, the same thing, you have to tell Python where your files are. So I have the same, your heart score, data science, and I have these in a Python file. So I have my cardio, my HL data, and I have another one called salaries. So I'm going to load those in, and I'm just going to copy these over, hit paste, and now these are loaded in. And now I can go to my cardio head, and there's my cardio. HL data, same thing, I've got my HL data and salary, you get the idea. To create a data table, we're going to go here, we're going to copy this code. And here's our data table of disease frequency with the cardio. You can also just run some simple math, kind of like what we did here. So we can do 1 + 1. And it gives us a 2. That's good. Okay, and you can do just like what we did in R. We can assign variables. So we gave it a 3. You can assign variables and then run some logic. So we had 4 runs scored and then 3 more runs scored. So that gives us a total of 7, for example. We can do, here's one with whether the team won or lost. So you have team 1 has 6 runs. Team 2 has 4 runs. So team 1, and it's a Boolean. It's called a Boolean. It's true or false. So did team win? True. And then you can click here and you can get the message. Nice job, team 1. So again, you can actually go deeper into your code development by doing these. All right, now let's look at a couple of other. We're going to do some. So this is called a. This is called a for loop. Let me do it. Let me do it a couple of other ways here. But let me show you a couple of other things real quickly. All right, so we went back to our independent sample t-test. All of these are in your notes page. So we've got our groups. We're going to run the file. And again, it's just going to give us the output. So the t value and the p value. We're going to do a one-way ANOVA by age group for BMI. F statistic, remember there's a T statistic and an F statistic, and they give you a p-value. This is 7.7 to the 5th power, so this is a significant value. This is a linear regression. We have 2 scale variables here, and it's going to give us our lin reg output in pretty good detail. We have logistic regression. Same thing. We get our LR output. So pretty easy to set up. Here's an example. We're going to do a box plot. So again, we have pandas, we have NumPy, and we have this matplot library. And when we do that, we should have a plot. So we do. So I clicked here. Just like in R, you can click on the plots. You can click on files to open a file. You can click on plots to get the output. Some other things you can do in Python, you could do if-then statements. So we're looking here at blood pressure ranges. So we've got our AHA blood pressure ranges. And then we have a systolic of 135 over 85. And that is hypertension stage 1. Now, let's see if my logic is okay. If I do 110 over 70, I've got a normal reading. What if I do 210 over 120? What should the output be? That should be a hypertensive crisis. Let's see if we get that. Oh, very interesting. This is actually a logical flaw in our actual guidelines. That number actually, if you look here in the logic, my if and elif, and this is actually how it reads in the guidelines itself. If it's greater than 140 over 90, it's hypertension stage 2. Look in the guidelines, that's exactly what it says. It doesn't say it's a hypertensive crisis. So I'm going to have to reconfigure my code. I'm actually going to have to put this up front to say if it's a hypertensive crisis, call it that. If it's not a hypertensive crisis, then run through this logic. You can also do what are called for statements, and these are for iterating through. So we have a list of symptoms for this patient, and so I'm going to click here, and I'm iterating through, and it's given me a list of symptoms that this patient is experiencing. And then finally, we're going to do what's called a while loop. And this is, you're going to keep running this loop while the conditions are continuing to be met. So this is in an exercise program, and these are different exercise output variables. And so this while loop, so you could do this in designing, for example, a cardiac rehab program. I showed you earlier this GDMT, and again, so you have to create what are called classes. So you create this, so we have a patient class, and then we have, in programs like Java, these are called functions. We're just defining, so we're initiating and optimizing the medications, and then we're creating a schedule for follow-up. So if I click here, I've got my initiated and my follow-up for this patient. And then now I want to create this. So here in this block of code, I've actually created a database, and I'm going to create tables and store records to these tables. I've already shown you those tables, so that you know that it actually worked. And then we're going to go through, we're going to add the patient, we're going to log the weight, the medications, the symptoms, and then we're going to create the scoring key, and then we're going to tell it what to do. So let's see if it works. And it did. So it's the same code you saw earlier. So the person who has a score of 0, which means everything is good, they're going to recheck in 4 weeks. The person who their scores are greater than 2, they need a weekly follow-up, and if it's a 1 or a 2, they're going to recheck in 2 weeks. Okay. So the last one here is going back to this Titanic survivorship. So again, we're creating, we have a bunch of stuff here we've added. We have a passengers data set, and then we have these factors. So the class, so we have first class, 0s and 1s, the 1 is the female, age 45, no parents or siblings. She paid 500, I don't know if it was dollars or pounds, but it's 500, and she embarked from Cork. So do you think she survived or not survived? Put it in the chat if you want to vote. Let's run it and see. So she survived. So it kind of makes sense. She was kind of an upper class person. And so her chance of survival was actually pretty high. Let's change these factors now. So we're going to, not first class. We're going to change this person to a male and 25. And this person paid half price and also embarked from Cork. So how do you think this guy is going to fare? You think he's going to have the same outcome? Let's see what our random forest. So this is using a classifier called random forest. So this is an analysis used in machine learning. And sure enough, he did not survive. So that's an example of how you can be using what do you need to do with you actually have to set up a training and a testing data set. So we're actually using about 70% of the records as training and only 30% as testing. So you can play around with these numbers, but that's in general how you do a random forest analysis. And then the last thing I want to share with you, again, we're really doing full stack coding tonight. So we've taken all of this code, but you also have to be able to deliver it in a meaningful package. So what I've done now is I've created oops, I'm going to have to pull this down so I can see it. Yep. It's right in the middle of my Zoom information. Let me pull it this way. So we've created this HTML file. So HTML is the language of a website. And what does that look like? So if I wanted to create a new HTML, I'm just going to call this, and we can assign it to CSS files or not. We're going to create it, and this is basic HTML. So you're going to have a header, a title, a body, and then a footer. And then you're going to have what's called a CSS page, a style page here. So we have this HTML file. We have a style sheet associated with it. So we have this red background. Maybe we don't like red. Maybe we want to do we're going to, oops. We want to give it a different color. And let's see what it did to my website. So it's actually relatively easy to style these pages. Again, we're going back to the code. You can also link your style sheet. So all you have to do is put in the reference to that style sheet, and it's going to do all of the business for you. I've also linked a logo on the top, but I can go in and I can change that logo. I can change it to a different file. I could put this, see how this is in the header. I could switch and put it into the body. Probably wouldn't look as good, but that's how that would work. So anyway, so that's a general page. So now let's go back to that code that I wrote. So we have, so it's literally taken it from that tracker on the heart failure symptoms. We've created a design, and I put it into a live format. This is what my design looks. And again, I have this style sheet here. So again, if I want to mess with my design here, I can do this, and let's see that yeah, whoops, here's my page. So yeah, change the font up here. So not too big of a crisis. But I've also created a style sheet, and I've also created a form for a dashboard. So this would be on the back end. I don't have any data plugged in here, but you would just attach it to the data set, and then all of those records would populate on this data sheet. So we've literally gone tonight in literally 1 hour from using a command line prompt to GitHub to doing statistics to writing code, building a web page. So I wish it was always that simple. It's not that simple, but let me pause here and see what type of questions or comments you'll have. And just like last week, I was talking so much, my speaker stopped working. So if anybody was trying to talk, I wasn't hearing you. Okay, so I think I'm going to go ahead and stop the recording.